Alright, welcome back everybody, it's Mr. Zabo again. I just wanted to let you know this will be a much faster video. This one won't take quite as long. A lot of the process that we have to do this next step is already done. We've already learned everything that we need to know, so it's just a matter of putting some of the pieces together. We're going to take this form, or this equation, which is currently in standard form, and write it in vertex form. So again, recall, vertex form is a times the quantity of x minus h squared plus k. The good news is we have part of this already. If I look at this, and standard form is ax squared plus bx plus c, this a and this a are the same a. So part of what we need is already done, because we already know that a is equal to 2. We do know that b is equal to -3 and c is equal to +2. If I go to my answer, and I can write my part of my answer in right away, it's 2 times the quantity of x. Now I need the vertex. So in the previous examples, and I'll just scroll back to those on the previous video, we were able to find the vertex using the opposite of b over 2 times a, and then plugging that into our function to get our y-coordinate. That's exactly what we're going to do now, except we just had to be able to piece together the piece of a. So I'm going to take the opposite of b. My x-coordinate is going to be the opposite of b. b is already -3. The opposite of that is +3. Over 2 times a. 2 times 2 is 4. So my x-coordinate is at 3/4. That's enough information to go and plug right into my formula or my function right away. It's going to be minus 3/4, because I know my h is equal to 3/4, my vertex. Now to find k, my y value is going to be equal to 2 times the quantity of 3/4 squared plus -3, so I guess minus 3 times the quantity of 3/4 plus 2. So I'll take a quick second here to go ahead and talk through some calculator stuff. Yes, I could just use 0.875 as a decimal, and that's not wrong. It's an exact answer. I do not want you to round that. Do not tell me it's 0.9. Do not tell me it's 0.88. That's a lazy out to just round something that's already 3 decimals. I do prefer that if it's something this simple that we can make it a fraction, but I'm not going to be that picky right now. We used 3/4 as a fraction. I could have used 0.75. Now I'm going to use 0.875 as my decimal, but I want to make it a fraction. Remember how to do that. That's the math button. Choose the frac option. That was number 1, so it's taking my answer, converting it to a fraction. I hit enter again, and I get 7/8. So now I know that this is equal to 7/8. That's my y-coordinate. I'm going to add 7/8, and I'm done. What I want you guys to do is press pause and try example 2, please. So here in example 2, we did not have our fraction issues, but once again, the a was -2, and that appears here. I took the opposite of b over 2a to get my x-coordinate of 2 minus 2. Substitute that in. Everything goes into my calculator. I get 11 as my y-coordinate, and it should have been plus. Alright, last thing I want you guys to do as part of this video is I want you guys to pause, and if you have the time now in class, try numbers 1, 2, and 3. These last 3 problems. I will be taking a couple of seconds pause here myself, and then I will start displaying answers. Alright, so here for example 1, we find our vertex, we find our axis of symmetry. This is a minimum, and the intercept for the y-intercept is at 0, 10. All real numbers for the domain, and the y has to be greater than or equal to -6. I'll take another 5 to 10 second pause here before I display the answer to 2 on the back. For number 2, we use negative 1/3 as our a, and we were able to calculate that our vertex is at negative 6, 4, so it becomes x plus 6 quantity squared plus 4. One more short pause here before we get to the final problem. Okay, and this one was a little bit trickier to graph. We've got a vertex at 0.5, negative 4.5, so an axis of symmetry at negative 0.5, and the y-intercept was at 0, negative 5, so that was a much harder curve here to graph, but that should look like a curve. Mine is okay, not fantastic. Alright, that's it for this lesson, ladies and gentlemen. Make sure you have questions ready for me, and we can go over anything that you have. We will be taking another look at section 4.2 again tomorrow, and I will have some practice problems that I want you guys to use Google Forms for that I'll post into our classroom.